Welcome to UNICOM Engineering's Flawless Execution Podcast. I'm your host today, Amy Shadroff, and today we are exploring innovative cooling solutions with our partner, Accelsius. And I'm joined by Austin Hypes, UNICOM Engineering's Chief Technologist and VP of Engineering, and Rich Bonner, the CTO from Accelsius. Thank you, gentlemen, for joining us today.
Great, thanks for having us.
Rich, let's start with your background at Accelsius and what led you to develop a two-phase cold plate cooling solution?
So two-phase cooling has a lot of unique advantages over other forms of cooling. The way I like to teach two-phase cooling and its advantages from the start is that essentially when you're using two-phase cooling, you're boiling at the surface of a chip. And boiling inherently stirs fluid locally to the wall, which is right where you want it to be. So you compare that to other forms of cooling where you're just trying to sort of brute force blast water, kind of like a fire hose at a chip. Using this boiling process is much more elegant, gives us much more performance.
And how long have you been doing this type of work?
Two-phase cooling has been around for a long time. You could even go back to, I imagine, cavemen boiling water, right? So you're really borrowing off of that physics. Two-phase cooling as a science has really been emerging probably for the last 50 or 60 years. If you kind of fast forward to something more close, it's really been taking off with the advent of GPUs, CPUs, and high-power processors. That line of work has probably been more developed over the last 2 decades, leading to where we are today.
And can you make the connection for me on how AI and ML is now affecting that?
Sure. So if we look at thermal management in data centers and servers and processors, it's been a very conservative market where most of the processors were geared towards air cooling simply because it's reliable and it's well known. But AI and ML in particular are demanding these processors that are really putting off a lot of heat. So that's causing the thermal industry to react by looking at some of these more advanced technologies that have been in development.
And how is this different than other technology that's out there?
Well, it's different in terms of the physics that I talked about and the performance. It's also different in terms of some of the other reliability-based benefits. So one of the unique things about two-phase cooling, it allows us to use refrigerant-based working fluids. And refrigerant-based working fluids do not conduct electricity at all. So if there's a leak or any issue with your system, you don't have to worry about destroying several $1 million of IT equipment that's in some of these AI racks. Whereas if you're using water or other types of solutions, you have to worry about that. It does cause lost sleep. So that's one of those unique advantages.
Austin, would you like to weigh in on the conversation?
Yeah, so essentially some of those advantages in two-phase liquid cooling, especially cold plate, is that it's allowing you to essentially take your air conditioner straight to the chip. You're not having to go through air, you're not having to go through water, and the more loops you can get out of the process, the more efficient your cooling is going to be. It also allows for a much higher heat rejection than some of the other solutions available today, whether it be air-cooled or more of a single-phase, cold plate solution. And what that really means is that on the heat rejection side of the data center, you can use things like higher water temperatures in your water cooling loop. And by using higher water temperatures, it allows it to be more energy efficient. You don't have to run compressors. You can do things like dry coolers. And those dry coolers are a closed loop system with no wastewater. So not only is it more energy efficient, but it also allows many data centers to use little to no wastewater, which is important in a lot of regions of the world.
I know there are a lot of refrigerants out there that you can use. So which one do you use? Which one do you find is the best?
So we tend to focus on refrigerants that are so-called fourth generation refrigerants. The reason we focus on those refrigerant families is that their GWP, global warming potential, is close to 1. So if you use a refrigerant that has a GWP of 1, you get all the environmental, energy savings, water savings benefits as well. Really, we think that's a win-win-win. So we tend to stick to those most modern forms of refrigerant.
Is this a situation where that refrigerant could one day be outdated like we've seen in our air conditioning systems where we've gone from the freons to something else because it's not energy efficient enough to be used?
Yeah, I think, working with a lot of the fluid manufacturers, they're always trying to come up with the next best thing. I mean, I think we see this pattern where every maybe 15 to 20 years they come out with another generation. And I think there's going to be further improvements in the next generation, just like we saw from third generation, fourth generation.
When you use AI and ML, you've chosen to build on Dell platforms. Can you tell me a little about why you've chosen the Dell platform and why it's the best for your needs?
Sure. Yeah, so UNICOM Engineering and Accelsius, we both have an excellent engineering relationship with Dell. So not only is Dell an excellent tier one partner, they have a wide variety of solutions for building AI factories. And because of that tight working relationship between our joint engineering groups and engineers within Dell, it allows us to customize a system for alternative cooling, such as two-phase cold plates. So it's not just a matter of taking cold plates and putting them on CPUs and GPUs and other accelerators. The whole system is actually crafted around it with custom firmware to make it an ideal situation for the energy efficiency and the noise. So like I said, it's not just bolting on a solution to an existing platform. It really is an entire system level approach to minimize both the power consumption and the noise it will generate.
And are you always updating that platform to whatever the latest and greatest is?
Yeah, the Dell platform is always looking to incorporate the latest and greatest processors. I'd also say that Dell is one of the leading server manufacturers at liquid cooling. So it allows us to, being as our solution, it looks very similar to a standard liquid cooling solution, we can leverage a lot of that engineering that's already in those products to quickly implement ours. So basically Dell's been staying at the forefront from a thermal perspective and makes it easier for us as well.
Is there a warranty on this solution at all?
Yeah, absolutely. So that's part of what UNICOM Engineering brings to the table. So working with our partners, Accelsius and Dell, we are able to design that solution that's fully validated by all parties, including UNICOM Engineering, and that allows us to offer a full comprehensive warranty on the platform, the same as if you were to buy it from the tier one manufacturer directly, and that includes all levels of service, all the way to on-site repair and on-site replacement.
And how long is that?
So standard warranty is 1 year, but we offer uplifts all the way to 3 years or 5 years, depending on what that particular customer or data center needs to match all the other equipment they might be buying in conjunction.
So the customer doesn't have to be concerned that since the technology was tweaked a little that they've voided the warranty, correct?
Yeah, absolutely. That's one of the main value adds that UNICOM Engineering offers.
And how do you two work together? I mean, how does that process go? And can you describe how you work with Dell and how you work with Accelsius?
Yeah, so with UNICOM in the middle, so we start with our partners' technology. So Accelsius has done an excellent job designing two-phase cold plate cooled hardware. We then take that and incorporate it into the actual server products, as well as working with and designing and validating things like those custom firmware elements that are going to be required. Then with those modifications, we do the full integration and testing so that when it is deployed on site, it is a fully validated, tested system, so you're not worried about is it going to work when I first turn it on, because it is not the first time it's gone through that full validation.
And when do you come into the process?
We come into the process when a new server comes out, and we identify some customers, or UNICOM identifies some customers who want two-phase cooling. We come in and develop the cold plates, tubing, manifolds, whatever is needed to implement our solution into that new server architecture. And a lot of times we're leveraging a lot of UNICOM's expertise to make sure we're capturing any features that are going to be required for them to offer their warranty or just to make it a fully functioning solution. So I think really we're working hand in hand, kind of in parallel during that product development process.
And how long would you say the whole process takes?
It does depend on the solution. Each of the cooling aspects is customized for an individual platform. When it's working with existing technology, it can be a matter of just a few months. When we're really working with cutting edge technology, things that haven't been released to market yet, could be 4 to 6 months, but we do try and time it as close to the market release from those OEMs as possible.
Speaking of cutting edge technology, things are advancing so rapidly in every industry these days. What do you see in the future for your industry and how things may change in the near future?
Yeah, so it is readily apparent, I think, to everybody from all the keynotes and everything from NVIDIA, from Intel, from AMD and others, that power consumption continues to be a main focus for data centers and enterprises. So it's all about achieving greater efficiency with the amount of power that you have or the amount of power that you can get. So we are seeing continuing innovations in things like the accelerated computer market for artificial intelligence and machine learning. Those chips are going to keep consuming greater amounts of power. So it's about how can we more efficiently cool those chips so that you get those continuing doublings of performance every generation or so, while not doubling your power consumption to do that. And that's really what we're focused on for the next generation.
And how about you?
Yeah, I mean, that was very well put. I guess I could maybe even put some numbers on it a little bit. So if we looked at rack power densities, probably for the preceding 20 years, we were maybe approaching 40 kilowatts in a single rack. I think in the 2 or 3 years since AI has taken off, we're already at 120 kilowatts, tripling that. One of the keynotes, I think from NVIDIA just a few weeks ago now, showed that they're looking at 600 kilowatt racks in the next 2 to 3 years, right? So you're talking about a more than 10-fold increase in rack level power. The other interesting architecture that he showed was that they're talking about having servers, instead of being horizontal, now being used as blades. So that kind of, again, it's more power combined with different architecture. So it's going to keep us busy for the next couple of years, I think, for sure.
Yeah.
That sounds like a game changer for you if it's vertical instead of horizontal.
Yes, absolutely. And all these technologies coming out, quite frankly, they really can't be cooled with air. So you're always talking about some type of liquid cooling for these high performance, high power solutions. And that's why we're really focused on two-phase liquid cooling in general, because it is generally the most efficient method to cool it, not just today, but for the technologies that are coming out in the coming years.
I know we may have talked about some of this, but how do you work together to make sure you have a smooth implementation of these plans for your customers?
Yeah, so it starts with the technology roadmaps. So we are looking, 12 months, 18 months, 24 months into the future, really focusing on what technologies coming out do we believe our customers will want to deploy, so that we can get early access to those technologies to develop the cooling side as well as the system side, and have all that validation done as those systems are ready to the market. So.
And how about you?
Yeah, similarly, I mean, we work a lot of times with the chip manufacturers up front, because they're going to be the ones who are really specifying the individual cold plate itself. So we need to make sure we're ready as the two-phase cooling vendor to attack that. Then as those processors move forward, eventually they want to put them on servers. And that's really where we start interacting with UNICOM to make sure not only can we get the cold plates functioning on a chip, but make sure we have the plumbing solution to plumb 4, 8, maybe more of those cold plates onto a single server.
When does everything come together? When you're actually at the location, at the site, or is everything put together in advance and then you bring it complete to the customer?
Yeah, so everything is integrated and tested in one of our manufacturing facilities. That way, when it does get on site, it is, like I said, a fully validated solution. It literally is slide the servers in place, hook them up, they're already pre-charged, they're already pre-tested, they're ready to go.
And do you provide any education for the clients on how these systems should be used, or are they pretty much up to speed already?
Yeah, so there is a lot of upfront work that's done in the pre-sales process. Generally, as part of that installation, there is a handoff procedure that really shows the maintenance of the platforms. And of course, UNICOM Engineering is always there to provide service and support for those who don't want to do it themselves.
How important is your partnership to each other? It sounds like it's a nice marriage.
I'll say for us, it's very important. I mean, the warranty that he talked about, it really speaks volumes about I guess the credibility and the validity of this new two-phase cooling technology, because their reputation is so good. So it's critical.
And how about for you?
No, absolutely. We need innovative cooling solutions. Accelsius are experts in that market space with two-phase liquid cooling. So without partners like Accelsius, we don't have ways to achieve better power efficiency going forward with the solutions that our customers need.
Well, thank you both again for joining us today for this very insightful discussion. And if you'd like to learn more about implementing these advanced cooling solutions, please visit unicomengineering.com or reach out to a Unicom Engineering representative. Thank you so much for joining us today on the Flawless Execution Podcast. Tune in next time for more technology insights.
Thank you.